Got this grid. We want to color two of the cells black so that the two black cells share a vertex. That is another name for corner. So they share like a corner here, but not a side. So we can't shade two next to each other, for example. So they share a vertex as well, but they also share a side. So that's not allowed, whereas something like this would be allowed. And how many different ways can he achieve this? So I'm going to show you two ways to do this. First of all, let's just work systematically through every option. There's not that many, so this is a solid method. And I'll talk about an alternative way that you could do it. So if I start from the top left, the only one that I could shade if I shade the top left is going to be this one here. So I've dealt with all the ones involving the top left. Right, now I'm going to deal with the top right. So if I shade the top right, now I can either shade this one down here, or I could shade that one down there. So that's all the options where I've started with the top left, top right. Okay, if I go down here, now I've already dealt with the case where I do this one. So I'm going to ignore that. But that one would also go with that one as an option. And that's it. So now I'm left with, I've got the middle. Oh no, because if I do the middle, then that only gives me that as an option. I've already got that. So what about this one here? Then I could do this one, but I've already got it. So that just leaves me with that one there. And if I dealt with this one by itself, then I could get these two, but I've already got that. So I can see those are my only options. It's going to be 5. Here's an alternative way of doing it that would be particularly useful if I did with a larger grid and there were more to find, basically. So in this alternative method, I'm not going to actually shade them in. I'm just going to count how many options there are when I was to shade in one of the squares. So if I shade in this one here, I can see that there's only one way that I could do it because it has to be that, for example. Whereas if I shade in this one, there's two options, these two here. So I'm going to put a little 2 here to say that there's two options using that square. And I can proceed in that way. Here, I'm going to have two options as well. But just like something that's going to come into it in a minute is that I've kind of double counted because I've actually already counted this one when I counted up here. So I'm basically including it twice, and that's going to be a feature of this method. If I go for the middle, then there's only one option. If I go here, then there's two options. Um, and then here, there's two options as well. So I can count up all those options. There's 10 options, but like I said, this is the important bit. I've actually double counted because every square I've just kind of dealt with by itself, but some of them will be repeated. In fact, like I've double counted, like I said. So I do 10 divided by 2, which equals 5, and that's the answer. So this method is a little bit harder to understand, that's why I left it to the end, but it is a bit more powerful, especially if I were to have a larger grid. Just finally, a third method, looking at the solutions. This is quite a nice idea, so it's worth talking about. In the solutions, they don't like look at the squares, they actually look at the vertices themselves. So here, for example, how many squares are there that share a vertex but not a side? Well, there's actually 2. So we can actually count these up. So that gives us 2 possibilities, like this and this, or this and this. So slightly different approach here. Here I've got one possibility because it's this one and this one. And then here I've got one, and here I've got one. So if I add those up, that will give me the total possible number of arrangements, which is again 5. So that is probably the best way if you were to do a larger grid. You could do my method and then divide by 2, but this would be even quicker.